Okay, so today we're actually going to start learning Java instead of just the setup. Um, and if you guys have any questions, feel free to just, interrupt or post a question in the chat or anything like that. So, um, what I have here is just the first project that um, in IntelliJ that we created yesterday. So, um, the first thing we're gonna go over is um, a variable. So variables are like variables in math, um, in that they store a value that isn't necessarily doesn't have to be constant. So the way you create variables in Java is you type in the variable type. So um, the main basic variable types are integers, which you create using int. So that's just numbers, whole numbers, um, positive, negative. Um, you can also create a double, which is um, uh, it has it can have a decimal. It's a number that can have a decimal. You can create a boolean, which is either true or false, one or zero. Just that's all it is. You can create a char or a character that is just one character, I guess. Uh, you can create a float, which is a floating point number. So it's similar to a double, but the way that it works is different. Um, like how it is stored in memory is different than a double, and it can um, it it sort of a float allows for a wider range of numbers, but only in certain cases. It's at this point, it's not a super necessary distinction between the two. So, um, the other one is a string, and a string is uh think of it as a string of characters. So it's just it's text essentially what it is. And um there's a few other variables, but those are some of the main ones that you'll come across. You might also come across some that are called long. That's just an integer, but it allows for more numbers. So it allows for bigger or smaller numbers. Um, th- uh, so how you can create a variable is you give its type. So for example, I'm going to make a string. Then you put a space. Now, Java is not um, uh, it doesn't really care about spaces, as long as there's a space in between words. So I could have a whole bunch of spaces right here, and it will compile and run exactly the same as if I didn't have all those spaces there. But if I get rid of this space, then it will throw an error. So you need to have at least one space between the words, but it doesn't after that it doesn't really matter. You can have as many spaces as you'd like, it'll still run the same. So you put the type of the variable. Now you give it a name. So in math, that might be X or Y or Z or something like that. But in programming, it can be whatever you want. So let's just call this a string. Um, for naming, there's a few different types of ways you can name variables. Um, so one is called camel case, which is where the first letter of each word is capitalized. So if I have a multi-word name, it would say this is a new string. If it was camel case, it would be new string. Often what you'll see in Java is the first letter will be lowercase, but then each word after that will be capitalized at the beginning. Another way you'll see them being written is with an underscore. Um, that's not super common, but some people do it. Uh, those are the main sort of ways. I mean, there's people who don't like other people, who just don't put any capitalization or spacing in between them. The important thing is that you can't have a space in between your variable name. So if I can't call this new string, and I think that I can just put that as a name. So I'm gonna call it. I guess we can call it new string. And then you set so we could just stop there, put a semicolon, which a semicolon indicates the end of the I guess technically it's the end of the line, but think of it as the end of the statement, because that's how Java's like, okay, the you're done programming this statement, I can move on to the next thing. Uh, you have to have that at the end of each statement, but you could a new line is not counted at it. It's just counted as white space. So I could add as many enter like new lines here, and it will still compile fine. But you have to have that semicolon at the end of the statement so that Java will compile correctly. Um, that's sort of useful because once you start getting really long statements, like if you're checking if you have a if you need to check something and there's a whole bunch of things you need to check, or if you have a really long variable names, it's nice to be able to split that into multiple lines to make it easier to read the code. Um, and Java will still count it as one line. So it's a nice feature, but you have to make sure to have that semicolon. So we could stop there. What this has done is it's been like, okay, they want a variable, so Java will allocate memory for the variable, but there's nothing stored in it yet. And in order to store something in it, you have to set it equal. So you put an equal sign and then whatever value. And strings have to be encased in quotations. So the string new string is equal to that value now. So it in memory it's storing the new string, um, and now you can access that. So if you have later on in your code you want to um, say print out the string, to the console, you can just put in the name new string. You don't have to put in the actual string new string, if that makes sense. I probably should name them different things. But so how you can the different ways that you can assign variables. So string has to have the quotation marks. A char has to have single quotation marks. So that's what that would look like. An int has to be a whole number. So 1, 100, 10, 13, whatever you want. It just has to be a whole number. It can't have a decimal because that'll throw an error. Doubles, that can be set equal to just 1, or it could be set equal to, 0.2 or something like that. Like, it doesn't really care that much. And then a float, you can set it using, 1 or whatever. But most often, if you're using a float, what you should do is put the letter F after the value. So that just basically tells the compiler that it is a float and not a double or an integer or something like that. So as you can see, like you can just pass in 1 or 100 and it will still compile fine. But if you put F, that's sort of a best practice. And if you are putting in a decimal, then you have to put an F afterward to distinguish it from a double. And those are the main things. Also with longs, it's also best, you can just set it equal to a 1,000 or something like that, but it's best practice to put an L, either a capital L at the end of it, to just say it's a long. So the next thing is we sort of showed this yesterday, but printing to the console, which is really, it's pretty easy in Java. So what you do is you can do system.out.println with some parentheses and the semicolon at the end of the line. And anything that you put in between the parentheses will be printed out to the console. So I can put that the new string variable, which is the new string variable name. And now if I run this, you can see that instead of printing out new string, it prints out the value we set to the new string variable. And print ln is how you print something that's it will basically hit enter after everything you print out. If you don't want that, so here I can show you, if I print out the new string and then I print out the new int, so it will print out the new string and it'll print out that. If I run this again, you can see it prints out the new string, and then on the next line it prints out the 1. If you don't want that, if you want them both to be on the same line, what you can do is you can get rid of this ln, which sort of stands for line, and now it will just print out the things. So now you can see when I ran it, it's new string and then the 1 is right after that. And it won't add any spaces or anything like that. You have to do that yourself. Um, another way, so another thing you can do with variables is operations. So let's say I have the int new int. I can add another int onto that. So let's say I have the int new int, and then I have another int. Here, I should put it down here. Second new int, and I can set that to, let's say, 5. I can take these two and add them together out in the, so I can add them together, so I can take the new int plus the second new int, and when I print this out, you can see that instead of printing 1 and then 5, it'll print out 6. So it adds them together. It does this first, and then it will print out. But let's say you want to add the two variables together, but you want to save it to a new variable. What you can do is you can just do pretty much the same thing. So the added, I can create a new variable called added ints, and I can just take the new int plus the second new int, and now it will add those two together, and it will store it in this added int variable. So now I can output the added ints, hit run, and it's the same thing. There's the 6, and Bob's your uncle. But let's say you want to add, you have the new int variable, and you want to add the second new int to the new int variable, but you don't want to create a new variable. So you just want to basically set the new int variable to the new int variable plus the second new int variable. So you can do this pretty simply as, since you've already created the new int variable, all you have to do is put the name, put it as equal to, and then you can put new int plus second new int. So now if we print out the new, now we can print out the new int variable up here, and we can print out the new int variable down here, and you can see it prints out 1 first, and then we add the 5 right here because it adds the 2 and then sets it to the new int variable, and it outputs the 6. But there's actually an easier way to do this. Instead of, because you have the new int variable being set to the new int variable plus something else, instead of having it equal, instead of having this, you can just do a plus equals sign. So it will set the new int variable equal to new int plus the second new int. So it's just like, if we run it again, you can see it's the same output. It's just a bit shorter, and shorter is better because it's easier to read. You can also add different types together. So Java, it's pretty lenient on adding different things together. It'll still compile. So let's say we wanted to add this the the new int variable to the new double. So what we could do is we could put new double plus equals the new int, and you can see IntelliJ says it's okay, like it's not put in a red line or anything. And if we actually output this, you'll see 1 plus 1.02. It actually, or yeah, oh yeah, I set new int to 6 here, because 1 plus 5 plus 1.2, 7.2. Even though they're different types, Java will still add them together, which is pretty nice. However, you can't do it the other way because, or well, you can't do it the other way without losing data. So you can see if we put new int plus equals new double, and then we print out the new int, you'll see it'll still run, but it just gets rid of the 0.02. It'll make the double an int in the easiest way possible, and the easiest way possible is to just ignore the data. You can also add ints and longs, because they're pretty much the same thing, but you got to be careful because if you add a long to an int and that long is bigger than the max value for an integer, then it will also just ignore anything past what it can store. So yeah, it's you got to be careful when you're working with that. It's typically best to just only add together variables of the same type, with the exception of a string. So strings work a little bit differently, in the sense that if I take the new string variable and I add the new int variable, you can't really add characters because that's what a string is. It's just a list of characters. So you can't add a character to a number. So instead of like a mathematical add, it does concatenation, which it just puts the string value, so 1, so it just puts the number 1 at the end of the string. So if we print out the new string, you can see it added the 1 to the end of the string. So that's used quite a lot. At least I use it quite a lot because it's really easy to just add. You can add all different types of variables to strings, and it will, for the most part, it'll just work. You can also add strings together, and it works the same way. It's pretty self-explanatory, and so the other thing is the different types of operations that you can do. So let's create the second new int again. So what you can do is so you know how we had the plus equals? You can also do minus equals. times, which is just the asterisk, and divided, which is a backslash, and then yeah, then modulo, which modulo is the percentage sign. And of course, all these operations, you can also write it like this. They're they're the same, so you can also write, plus, minus, multiply, divide. You're gonna do all those. You can see though that it's saying that the new int divided by the new int is not all, or second new int is not always 0, which is true if you think about it. You know, what if it could result in a decimal value because it's division. But the modulo operator is basically, think of it as a remainder. So it will take the new int, divide it by the second new int, and instead of returning what that value is, it'll return the remainder. And instead of returning a decimal, it'll return an integer, which is basically, it's useful. You can think of it being useful as, let's say if I want to determine if a number is even or odd, I could take a number modulo 2, and if it divides, and if it's an even number, then if it's divided, if it's an even number and it's divided by 2, then modulo will turn 0 because there's no decimals, there's no remainder. Any even number divided by 2 is evenly divided out. And but if it's an odd number, then if it's divided by 2, it'll return a 0.5 or something, whereas the modulo will return a 1. Because it'll be like, it'll go through, and basically how you do remainders in math, it'll go through, and whatever's left over after it's done dividing all it can divide, it will return that value. So it'll return a 1, and if it returns a 1, then you know it's an odd number. So those are the main operations that you can do with that, with just characters on your keyboard. Let's see what else. All right. So far we've just been talking about, I guess we should talk about scope. So this public class main, this is a class. So think of it as like a container. And each class is its own container. And everything within that class is only within that container. How you change that is this public. So what public means is that from anywhere in your program, it can access this class. Typically, classes will always be public. There might be some exceptions, but for the most part, classes are always public. And the different types you can have is public, private, protected, and there's another one that I can't remember. But public and private are the ones you'll most commonly use. So public, it's anyone can access it. It's public. Private basically means only the class can access it. And usually, classes will be public. I don't know if they really will often be private. And then protected means that, so you know how we created this package? Protected means that only the classes in the package will be able to access it. This will make a little bit more sense when we talk about functions, but how it's used in variables is there's these things called scopes. And a class is a scope. And then this is a function. This function is a scope. And these characters and whatnot can only be accessed, like these variables can only be accessed within their scope. So if it's in a function like this one, this new string, if I was to go out here and just create a new function, which we'll talk more about functions later, I can't go in here and access the new string variable because it's only within this scope. It's pretty easy to tell scopes in Java because they have curly brackets. And what you can do is you can also declare variables outside of a function. So I can create a variable if I can type. Let's just call it. So I can create a variable that's outside of this function. And now, if I create that function down here again, you can see, one second. If I create this function again, I can access the outside variable string, and I can also access the outside variable string from inside this function. It's being a pain because of, so yeah, you can see I can access the outside variable function here. So it's because it's in the class and not in the function, it's accessible within that class. And you can also add those public static, like those public protected um, private keywords to variables. So if I put public, that means the entire program can access this variable. If I put private, which is what you typically want to do for variables, that means that only the code and functions inside this class can have access to that variable. Protected means the same. It means that only variables within the are only code and classes within the package, which is essentially the folder. Only the code running inside the folder can access this variable. So this is useful because you don't if you have all your variables public, it can create a huge mess when trying to look at your code, and it can cause sort of spaghetti code, which is everything's just everywhere. It's a mess, and you can't really read anything. So typically, you want private for variables that are inside the for variables, and you pass things around other ways that we'll talk about in a bit. The second thing that you might notice here is the static. A static variable, you can think about it as so you see how I have this new string here. I can create another. I can copy this and I can go into this other part, and I can create an exact copy of that new string. And they're different pieces of data. The static basically means in this entire program, there will only ever be one instance of this outside string variable. I guess it's a little bit more. Yeah, how do I? So basically, what you can do with classes is you can create multiple um sort of you can create multiple of them. So you can see how string looks a little bit different than the rest of these. See how char and they're all um this purple color and it's sort of italicized, and then string is a yellow and it's not italicized, and it starts with the uppercase. That is because it's actually a class. It's not uh I guess it's not these are called primitive types, which means um Java itself has these variables as or these types that it will store, whereas a string is a class, and you can use that um, string class to create strings. I don't know. I feel like I'm getting ahead of myself. Are you guys like sort of keeping up? Yes, no, maybe. If you're completely confused, I understand. Just let me know so that I can actually slow down, I guess. So the static basically means that you can only have one of this in the entire program. So if you create a copy of this main class, the static stuff won't be copied. Whereas everything like this function right here, how it doesn't have static, that'll be copied. Um, oh, I guess I am talking about functions. Anyways. Okay. So functions. All right, we're taking a little bit of a step back, I guess. Functions. So you can see how this main public static void main, that is a function. So when you create here, let's get rid of all this clutter. So when you create this a new program and you see this public static void main, that is a function, and it's this is a special kind of function because that's what gets called when your program starts. And uh, functions can be they're basically containers for code that will be run when the function is called. So when we were outputting hello world, it basically meant that this function was getting called at the beginning of running the program, and then the code inside was run. And you might also notice this string with these brackets and then args. So that is a variable actually. And these brackets here basically means it's a list. And the technical word is an array. And you can do this with every data type. So you can create a char array, you can create an int array, and all the array means is basically it's instead of just being a singular value, it's a whole bunch of values. So let's call this int array, and instead of just setting this to a whole bunch of variables like this, you have to call the new int array. So that's how you create a new array, is you put the keyword new, which is basically telling Java it needs to create a new uh, in this case it's an array, but you might have also like seen if you're creating a new object, then you'd create a new, like if you're creating a new string, you could also go like if you're creating a new object or something like that, you'd put new and then you'd put the object name. So if I was creating a new object of the main class, then it would feel like guess I gotta think. Okay. So yeah. So I guess maybe I should take a couple steps back and talk about how like some Java philosophies, I guess. So in Java, everything is an object, and an object is everything, I guess. You can think of an object as you would like an object in life. So, your computer is an object, or your phone, your keyboard, they're all objects. But they're different from, and that's sort of how Java will uh think about them, except how Java does its objects is it's just a whole bunch of data contained within another object. So when we create a integer, what Java is doing is it's actually creating an object that is of the type integer, and it's storing that in your memory. So an int is an object, and a double is an object. But what is special about them is that Java has specific ways on how you can assign data to those objects. So an int is special because you can just um, call the one, and it will um, assign the object of new int to the value of 1. So they're special because you don't need the new keyword. So if you have the new keyword, then you have this is another way in which you could create an integer. It's not the right way, but you're creating a new object. The name of the object is an integer, so it's a type of integer, that's the object, and then the value. And because everything in Java is an object, That's why you can create, um, I guess, I think that's, yeah. So going back to the arrays, you create the um, char array. You have to use that new keyword to create a new object, because instead of being something um, that Java is special, it's now actually creating an object. So you're using the new, so you're creating a new object, and then you put the name of the type of data that's going to be stored, which is a char, and since it's got these brackets, that means it's an array, and there's two ways you can go from here. So the way arrays work in Java is you have to know the length of the array that you're going to use before like when you're creating the array. So if you just want an array of 1, that means that there'll be one sort of slot for information to go in. So you can uh if you think of it as a list, it's just a list of one value, which is sort of pointless, but what you can also do, but you can put any number in there. So now there's 10 um uh character objects in this object that is containing all of them. So you can think of a list as just another container for just a whole bunch of objects. So this is where, you know, everything's an object sort of comes in handy, because if you think of everything as an object that can um, have objects as um, they're called childs and parents. So the array object is the parent object, and the child objects are all those, like in this example, it's all the characters that it's 10 characters that is stored in this list. And how you assign variables in this array is you, since we named it char array, you call the char array, but instead of just having the name, you put the bracket and then you put the index. So yeah, the index of the value that you want to set. So let's say I want to set the first value. Now in programming, instead of starting counting at 1, you start at 0. So if you want to set the first object in a list, you set object 0 to that value instead of setting so basically think of everything is shifted down 1. So the first object is at index 0, the second object is at index 1. It's and so on and so on. It's sort of backwards from how we think about it, but it makes sense from sort of a technical standpoint. Um, so if we want to set the first um, character, if we want to set the first character in this list of characters, we say the name of the array, the curly brackets, and then the index of the value we want to set. Then we use the equal sign, and then we can set it to whatever value we want. So that. So now we have an array that can hold 10 characters, and we just set the first character, which is index 0, to A. And we can copy this, and it'll go all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll go up to 9 because that's 10 objects starting from 0. Now, you can't set the 10th object because are you can't set 10 because the length is 10 and it starts counting at 0. So that's something that it's a little weird to get used to, but once you get used to it, it starts to make sense. But let's say you already have all the values that you're going to put into this array. So, we're just putting in a whole bunch of A's. We already know what it is. We don't need to set each value individually. Instead, what we can do is we can get rid of the 10, put some curly brackets, and add all of our values there. And so on. So now we've created an array of length 3, which Java will figure that out for us because there's only 3 objects. And each of these objects will be set. So the first one will be set to A, the second one will be set to A, the third one will be set to A. But we could also change these, so we could make the second object B, third one C, something like that. So then if we were to print out char array, print out the first one, you can see it prints out A. And if we print out the second one, which is at index 1, B, so on. And that's how you access values within an array. So that's what this is. Instead of characters, though, it's a string. So it's you can use that in your program to sort of change values. What this is actually it's actually just values that are given in when you start the program. So that we'll come back to, but you just think of those as inputs into your program that are not set when you write the code. But back to the function part. This is a pretty good example of how you create a function. So the four things you absolutely have to create a function is a return value. That's the first thing you need, and a return value is basically what will the function give back. So the return value for this one is void. Think of void as nothing. It's not going to return anything, it's just going to run code. You can but you can also return objects. And so let's just do in an integer. So now this function will return an integer. The second thing you need is a function name. So let's call this one add2. So function names follow the same sort of naming scheme as variables. First first word is lowercase, second one is capitalized. Then you need these parentheses, and then you need curly brackets. So this is a very basic function. But as for things you can add to it, you can also add inputs. So this is the output is an int. Let's take an input as an int and call it an input. So that's just a variable. We've already talked about that. And since it's called add2, I think it's, that's what's going to happen is when we're going to take the input and add 2 to the input. So now the input has been added, has had 2 added to it. And so, but that's not it. You so now you have to so you've gotten the input and you've added 2 to it, but now you actually need to it's called return the value. So we've added 2, and how you can do it is return. And basically what this is doing is it's taking the input, it's adding 2, and then it's outputting the input, which is an int, which is right there. So I guess if you're following, great. But that's pretty much all functions are, is just taking an input, applying some sort of code to that input, and then an output. And that output is specified in the return. You can have more than one return, but we'll get into that a little bit later. So now this is a perfectly legal function that you could call in your code. However, there's a couple of other things that you can add. So the scope, that's one thing you can change. So you can make this a public variable or public function, which means that any anywhere in the function or anywhere in the program you can call this function as long as you have an instance of this class. Private, same thing. You can only call it from within the class. Protected, the package. The other thing you can add is that static variable or that static keyword, which basically it means how there's only one public static void main function. Now there's only one add2 function that can be added or that can be called sort of. So now we can go into this and let's say we have we want to add 2 to 1. So what's going on here is we're calling the function by just putting down its name, and then the parentheses, and then here's the input to the function. So we're inputting an integer because that's what we specified down here. An integer of 1. It's going to add 2 to input, and it's going to return input, and then it's going to print that out. So if we run, see it prints out 3. And that's what we wanted. We can call these functions anywhere in our code. They can, if they don't return anything, typically you'll see that I guess, yeah, here, what? The, um, so yeah, you can call them pretty much anywhere in your code, and if you have a return value, you could also call a function when you're setting a variable. So you could say int 1 plus 2 is equal to add 2 to 1. So now you're inputting 1 to this function, so it's going to jump down to here. It's going to add 2, and then it's going to return, so it's going to jump back up to here. So now this is essentially thought of as 3. So 1 plus 2 equals 3, and then if we output this value, it's going to be 3. So there's 3. Um, and that's how functions work in this main class. You can also have more than one input. So let's say instead of just adding 2, I want to add 2 numbers together. Then I could create a function that returns an integer. So it's a public function, which means it can be called anywhere. It's static, which means there's only one sort of instance of it. The int, that's its return value, so it's going to return an integer, and I'm going to just call it an add function. So it's a function called add, and it's going to take an input of an int, an integer called int1, and then separated by a comma, it's going to take in another integer called int2. Then you got your curly brackets, and then it's going to return int1 plus int2. And that's a pretty simple, it's a simple example of a function, but when you think about it, it covers pretty much all the functions of a function. It takes in inputs, applies some sort of operation to those inputs, and then it will return an output. Another way you can have a function is if it returns a void. So that means it doesn't return at all. And let's call this print. So this public static void, let's call it a print int. And it's going to take in an integer. Going to take in an integer, and what it's going to do is it's going to print that integer out to the console. But you can see I didn't put any return statement. That's because you don't need one when you're using a void method. However, you could just have it say return with no value or anything like that. It would just be straight up return, and that's another way you could return. But since we're just doing one thing and that's all we need to do, we don't need a return function because it's returning void. So we could change this to an int sum equals the return value of the function add, and let's add 1, and then you can separate the inputs by a comma, and then a second input, and then the semicolon. So the first input gets inputted into here, the second input right there, they get added, they return, that value is set, then the variable sum is set to the value that add returns, and then we could print out the sum. And then we don't need to do with any value getting returned because nothing's getting returned. And you can see it outputs the same 3. And you'll also see that IntelliJ also grays out. And if you hover over this other one, it says it's never used. This is just a way, that's just a thing that IntelliJ does to try and clean up your code so you don't have a whole bunch of functions laying around that don't do anything, that aren't used. So we could actually just delete that and it will still run perfectly fine. So that's how functions can work. And if you guys want, we can continue, or we can call that a day and, be done. Okay. All right. I guess calling it a day. All right. So tomorrow we'll go over more of what these classes are and what objects are, and then how you can use these functions effectively. Okay. That's all.